in here, meaning like, guys, if I plug a 2 or a 4 in here, if I plug 2 in for I, do I get 2 out?
Yeah.
If I plug 4 in for I for my input, do I get 4 out? But if I plug 5 in, do I get negative 5 out?
No.
Okay, this one's kind of tricky because this becomes the same as I times negative 1 to the I power, okay? And let me show you why this is true. We've got to make the odd values what kind of a number?
Positive.
Okay, odd values have to actually be negative. Okay, just check this real quickly. Plug in 1 right here for me, for I. Okay, you agree we would have a 1 right there, right? And then what's negative 1 to, I plug 1 in here for I as well. What's negative 1 to the first?
1.
Negative 1.
So this becomes like 1 times negative 1, which gives me that output of what? Okay, plug 2 in. Okay, got a 2. What's negative 1 squared going to be? Not negative 1. Negative times a negative would be, anytime this I is even up here, this is what kind of a 1 then? So we've got like a positive 1 times your even number you're plugging in here. Anytime I is odd right up here, then what are you going to get? Negative 1. So it turns out that the summation says, okay, to write this in summation notation, you say we're going to do all numbers, starting with which term here? First term going all the way up to the what? 40th, and that would be I times negative 1 to the I power. That's a tough one, okay? Now, I think you can figure out the next one, okay? I'm going to change this 1 to 1 over 1, okay? We have to write this using what notation, kids? So we're going to make that goofy looking letter. What's the name of this letter? Sigma. Okay, you're always going to start with, in this case, this is the first term, right? Let me ask a question.
This one keeps going.
Keeps on going forever. Is there an ending there?
Nope.
No. So if this doesn't end, this is going to where? That guy would tell you over there.
Infinity and beyond.
So you're going to put the symbol for infinity up here. This has a starting term, but it goes on for what? You thought I was pointing at Jaden?
Yeah.
Jaden, did you think I was pointing at you?
Yeah.
Oh, I'm sorry. Did your heart rate go up a little bit?
You wouldn't have remembered.
I didn't make you have a panic attack, did I?
A little.
A little bit? I'm sorry. I didn't mean to. Okay. Okay, let's talk about this. You notice the pattern in this? Okay, I think it's a good idea for you guys to get in the habit of this. Say, okay, my first term is this. My second term is this. Third term is this. What do you notice about the tops and all of them? They're 1. Okay, so it's going to be the summation of all terms, starting with the first term, and then you're going on forever. Okay, we're going to have 1 over something. Okay, how is this 1 related to 1? The 2 related to the 4, the 3 related to the 9, the 4 related to the 16.
Oh, add 4, add 5, add 6.
Okay. But is there like one operation you can do to all of those values, 1, 2, 3, and 4, to
This is
form
the hardest thing ever.
one? I know, it's tricky. Okay.
What do you
I don't even understand what we're doing.
What's a 1?
numbers?
What's a 1?
How would you turn 1 into 1, a 2 into a 4, a 3 into a 9?
Double.
Well, not double, a 4 into a...
It was so much
Who
time
said that?
before we
Divide by
did that.
Say it again, Theo. Think about that. One pattern would work, would be a square. What's 1 squared?
1.
2 squared.
I knew how to do the first one before we
Yeah.
used this symbol.
4. That's 3 squared, right? That's 4 squared. So guys, forget the symbol for now. A pattern for this would just be 1 over. Instead of using n, we're using what variable now in summation notation? 1 over I to the what? Okay, so if you forget the notation part right here, that's not there. Do you get the 1 over I squared for the pattern right there? Okay, then the summation part out front is just saying you're going from the very first term, and this saying, so how many terms are listed up here?
4.
And when they go dot, 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 that just tells you right here, is that ever going to end? They're saying you're going to start with the first term, and you're going to go on to the, you're never going to end term, right? And this is your sequence right here, okay? This one, same thing. Your pattern is I times negative 1 to the I, but you're starting with the what term here? First term, and how many total terms were there?
4.
40. That's why the 40's up there. Okay? So let's see if we can't make better sense. Once we've got them written there, that's the hard part, writing them. Okay? Here's the next one, finding the sum of a series. Okay? Now guys, be careful on this one right here. This is saying start at what value? 3 and go all the way up to what? Okay, so here's the deal on this. We got to find the what here, kids?
Sum.
Okay, watch this right here. So what I'm going to do is say, all right, we're starting with k equal what value?
3.
But it must go all the way up to, so I'm going to put a k up here. Okay, so the first k value you're going to start with is 3. And we're going to go all the way up to, okay. And then our summation values down here. I'm just going to put the little summation signal. Okay. All right, plug 3 into that function, 4k minus 1. What do you get out? If I plug 3 in this mess right here, what would you get out? 11? Because 4 times 3 is what? 12 minus 1, we're going to get what? Okay, next one, plug 4 in, what are you going to get out? Plug 5 in, what are you going to get out? Anybody seeing a pattern yet? Just going up by 4 each time, right? Okay. What's 6 going to get you? So that means 7's going to get us, yep, and so on. Can I just keep going up by 4 now? And what would the last one be? Okay. Now kids, it said find the sum. So once you found your values for each of values k being 3 all the way up to 9, you're simply going to take these values right here and do what with them? Add them all up. So the summation then becomes, I'm going to write this down here, the summation, when k is equal to what value to start with? 3. And again, now they're using what letter? Doesn't matter what letter you use, okay? The k is just like an n or an I. They all mean the same thing. Up to 9 is going to equal all those numbers added together right there. Oh, let me think. 46 times 46 times 3 is 120 and 18, 138 and 23. Is that 161?
Yep.
That all add up to 161?
Yep.
Awesome. So if you want 11, 15, 19, 23, 27, 31 plus 35, do you understand where I got all those values just now?
Yeah.
Do you understand why the k values only go from 3 up to 9?
Yes.
Okay, and then once I got those summation values out for 3, 4 individually all the way up through 9, what do we just simply do with them? And what do we get for a value? 161. Okay, finding the sum of a series. Okay. So when you see it like that, does it kind of help you go back into this and help you understand why we wrote this the way we did? Like my first timer, 1 over 1 squared would be what? Would be 1. 1 over 2 squared would be 1/4, right? 1 over 3 squared would be what? 1 over 3 squared would be 1 over 9, right? 1 over 4 squared would be what? What's the next number going to be in this sequence?
25.
1 over 25. Why did I put 1 down here?
Because that's what you start with.
Because that's the first term. Why did I put infinity up here? There's no end to it. Okay? You alright with that? Okay. It'll get easier. I know it's very new for you.
I don't think it will.
I think it's just because the last whole try we've been working with shapes. It's kind
I
of
know.
weird doing formulas.
Okay, so here's a core concept. There are some special summations right here. Okay? One of the special summations is the sum of n terms of 1, meaning here's the deal. It says, okay, I want you to start at what term right here? And go up to the nth term. But is there an n right here? No, they just say 1. No matter what n is, you're always, that value is going to be 1. So what this table is kind of saying is this. If I had a table that started at, let's put I right here and then put your summation down here, like this. Okay, let's just do maybe, is it okay if I pick n to be 5? Is that okay?
Mm-hmm.
Okay, so like if I pick 5 terms, 1, 2, 3, 4, 5, okay? All right, go into the description right here. They're saying when I is a term right here, what are you going to get for an output? Or how do you find your output? Well, it would just be what value? 1. Okay, so then that means this is also saying, this is like saying no matter what term you're on, your output is always going to be what value? So the second term, its output's gonna be what? And the third term is gonna be what?
1.
And the fourth term is gonna be what?
1.
And the fifth term would be what?
Again, 1.
Okay? Now guys, if I did the summation of all these right here, what is this gonna add up to?
5.
Okay? So this is saying the summation of I equal the first term to the nth term of the function 1, it's gonna equal what value in the end? N. So this is just gonna equal, how many terms were there? 5. This is gonna add up to what? 5. Only if there's a what over here?
1.
So what if this n was 22? What would this n be? Okay, so this is equal to, in that case, 5. If n was 22, then we would have how many ones down here? If I went 22 terms, how many ones would you have down here? And if you added all 22 ones up, what would you get? Okay, so this is the sum of n terms of what? This is like saying, I want you to take n ones right here, and in our case, maybe it was 22 ones, and add them up. That would total 22, okay? Now, one you're going to see a lot of, and this one's an important one. It says sum of the first what? N positive integers. It's given to you as n times what? N plus 1 over what? Okay. Now, keep in mind, what has to be right over here?
1.
Okay, so what they're saying on it is this. Okay, let's put our I up here. And let's put our summation down here again. How many terms do you want to go again? 5? Is that okay?
Yeah, 5.
So 1, 2, 3, 4, and 5. Okay, so they're saying if I is 1 right here, you're plugging it into the function right here of what? Just I, right? Okay, well, what if I plug 1 in for I, what am I going to get out? What if I plug 2 in for I right here? What if I plug 3 in for I right there? What if I plug 4 in for I? Anybody want to guess what I'm going to get when I plug 5 in for I? 6? All right, you jokers. Okay, now they're saying if that's the case right here, what do you notice about the inputs and the outputs this time? They're exactly the same thing, okay? The deal on it says this. If you have that case right here where the inputs match the outputs, your sum can be found by doing n times what? Over what? Okay, so suppose this went up to like 800 here, kids. I don't want to put all 800 in there and add them together, do I? Okay. Here it would be pretty easy to add these up. What's 1 and 2 add up to? 3 and 3, 6 and 4, 10 and 5 more. That's going to add up to 15, right? Okay. But they say that summation is the same as n times n plus 1. What was n right here? How high up did I go?
5.
Okay, so this is the same as 5 times 5 plus 1, which would be what?
6.
Over what?
3.
What'd you tell me this added to?
30.
Ah, this added to what?
15.
15. What's 5 times 6 make?
30.
Divided by what?
2.
Which is?
Later, Gator.
Same thing, right? Bye.
Track?
Huh?
Track?
I know.
See ya.
Okay. Good luck. Jump high. Helium in the shoes. Suck on some helium balloons, too.
He's so awkward.
That was very awkward, yeah.
Track. Track.
Please delete boys varsity track at this time. Please delete boys varsity track.
All right. Now, guys, this one here had what value right here?
Track?
Track.
1.
This one only works if what's here.
1.
This rule only works if there's a what here?
I.
Just an I. This rule is only going to work if there's just what? Okay, let's do the same thing with this. This is the sum of what?
First n
Sum of,
squares.
okay, so that means I to what power? Okay, let's do this right here. I and summation right here. So let's do the first 5 terms again. 1, 2, 3, 4, 5. Kids, I could find all the terms. If I wanted to go up to 800, I could find all the terms and add them. That's not a problem to do, okay? But they give you this rule that says, if you do have I squared, the answer to all the sum of this, adding all those up, is going to be n times n plus 1 times what? 2n plus 1, all over what? 6, okay? Let's just do the work above here. What's my n value here, kids? How many terms am I using in this example? 5. Okay, before we even figure out our summation values down here and then add them up, let's see if this works. What am I going to plug in for n? Okay, so we're going to have a 5, and then the n plus 1 would become what? 5 times 6. All right, 2n plus 1 would be 5 times 2, which is 10 plus 1 more. Over what? 6, right? Okay, what would the 6's actually do right here? This is really going to become 5 times 11, isn't it? We think the sum should be what value according to that rule? 55. Okay, kids, if I take 1 and throw it in for I squared, what's 1 squared become? What's 2 squared become? How about 3 squared? 4 squared. And 5 squared. With a little bit of luck, this should add up to what value? Okay, so if you see an I squared summation, this formula can save you a lot of time instead of listing stuff. But let's just double check. What's 1 and 4 going to add up to? I'm at 5. 5 and 9 is? 14 and 16. 30 and 25 add up to what? By golly. Works, right? Okay, so the thing you're looking for is this. You're either looking for a 1 as a special formula for a series. You're looking for just what over here in this one? I, or you're looking for what right here? And you got to understand, n represents the first term or the last term? N is going to represent the last term. Question? Yep. Okay.
No.
Can I also?
Yep. All right.
Can I go?
Yep.
Everyone just take a field trip.
I thought we were done with it.
Oh no. Okay, let's talk about this. Are we on the last example? Yep. All right, I like this one right here. Okay. Kids, I think we can apply what we just learned right there with those rules. It says as part of an experiment, a teacher gives 1 paper clip to the first student to enter the classroom, 2 to the second student, 3 to the third student, and so on, until the 25th student receives what? 25th. Okay. So if I was the 17th student in, how many paper clips would she give me? 17. The question becomes, what is the total number of? Now, could I go 1 plus 2 plus 3 plus 4 all the way up to 25?
Yeah.
I could. But I want to understand this. Let's just talk about this right here. This is like the first student walks in. This is like the first student that walks in. Oh, shoot, Parson, where you at? LaPorte City, Durka, Durka, Durka. Okay. First student walks in. First student gets how many clips?
1.
Second student walks in. They get how many clips? Third student walks in. All right, and I'm going to do this dot, 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 all the way up to the 25th student gets what? Now, if I back up on this right here, I'm going to go back to the previous page. Okay? Kids, take a look at those special rules right there. The situation that's being modeled right there in that story problem, is that the sum of n terms of 1, meaning you always get an output of 1? Is it the sum of first n positive integers where my input matches my output?
Yes.
Yeah.
It's this one right here, right?
Yes.
Okay? So if I know that this is the summation right here where we have first student walking in, last student would represent what number? Isn't this really the same as a summation from 1 student up to 25 students of this function right here, I? Okay? And we can find this answer easily by doing n times what? N plus 1 divided by 2. Okay? So what's being modeled in this problem is one of these special series right here. So here's the answer to this. Next page. Oh my gosh.
You missed it.
I did.
And you drew
The dark side is taking over. This is, again, this would be the summation right here. Okay, I equals 1 up to how many students?
25.
Okay, I'm going to put an I here because that was the rule for inputs matching the output, right? But that's equal to, kids, we know what this is now equal to by rule n times n plus 1 all over 2. Wasn't that rule for that? Okay. Well, n represents the highest number, or the last term in this case. So what's the end value we're going to plug into this? So the number of paper clips that teacher hands out is going to be 25 times what? 26 divided by 2. Okay? Somebody punch that in. 25 times 26.
What is it?
325 paper clips there. That is. Okay? $325 paper clips to hand out. Theo. Yeah. Okay?
Jesus, we got 4 people in class.
You guys must have drank all the water at testing today. Okay? Hey, I think that's the last example, isn't it?
Yeah.
Okay, so, guys, again, I'm going to tell you right now, some of this stuff's going to get a little tricky here, all right? I'm going to be honest with you. You're going to have to look at things, and it's going to be like, no, that doesn't work, okay? Again, I get that sometimes you want instant satisfaction, but you're going to have to think about this a little bit. But we're going to work together through some of this here. So, questions on anything so far? Oh, where did that go? Guys, good? Okay, I'm going to stop this.